the last part of our study of acids, bases and salts, where the major aspects of the chapter we have studied. But it so happened that whenever we entered into discussions, we happened to talk about something called as indicator. And if you remember a small analogy that I had given, that on road you have some indicators which shows you red light, green light, these are the main things, and maybe orange light or yellow in between. So what are these indicators doing? They are basically indicating you that something is there to change. It is supposed to change in the coming time. A red light indicates that all of us have to wait. A change to green light essentially tells us that we can start moving. So there are indicators that we use here to determine whether compounds are acids or bases. Some minimum studies of this you have done in your earlier classes, but a more deep study that we are going to do in this part. But before that, the answers for the assignment that was given in the earlier part, write the chemical name and formula for the following compounds. This is nothing explanatory, it is just the idea that you have about various compounds and its chemical formulas that we have. So baking soda, it is NaHCO3, washing soda Na2CO3 10H2O, bleaching powder CaOCl2, which is also called as hypochlorite, calcium hypochlorite, and gypsum, which is calcium sulfate. You can also call it as dihydrate because it is 2H2O. So these are some of the formulas that we have for these compounds. Which compounds are used for the following? Softening hard water. All this was seen in the uses of these salts in the earlier part. Washing soda is used for softening of hard water. In the textile industry, we use bleaching powder for bleaching cotton and linen. Soda acid for extinguishers, this mainly because we use baking soda because carbon dioxide is given out from that, which is not a good supporter of combustion. And finally, supporting fractured bones, this is plaster of Paris that we use. Plaster of Paris should be stored in a moisture proof container. Why? Now that is because the moment you have its reaction with water or say moisture also. What is moisture? It is the vapor form of water which is present around us. So if this plaster of Paris gets in touch with moisture, then it absorbs water and rather forms the starting compound, which is gypsum. So this is about the answers for the earlier part that we had, and now we'll study about indicators. So first of, what is an indicator? It will indicate to us whether a particular compound is acid or a particular compound is a base. Now what about salts then? It does indicate about salt also. How? We shall see it further. So you can see that these indicators generally give an indication about whether it's acid or base. Some important examples like say methyl orange. Now this is one indicator that we use where methyl orange will show red color in acidic solution, yellow in basic solution. So a change in color will tell us whether the solution is acid or basic. Similarly, we have phenolphthalein. Now phenolphthalein will remain colorless. See, actually the color of phenolphthalein is colorless. If you put acid in that or the other way around, you put phenolphthalein in an acid, it will remain colorless itself, but if you use it in basic solution, we see a change in color to pink. Now that change in color indicates that the compound is basic. So this is about a general introductory aspect about indicators and what is one of the best ways to identify these indicators. We have a component called as litmus paper. So what is this litmus paper is? A nice rectangular piece of paper that we tend to have. We also have it like in bunches also, where we can get two types of litmus papers. One will be blue colored papers, another one will be red colored papers. So suppose you take a solution, suppose in a beaker you have some solution. Now if I put a red colored litmus paper in this, now suppose I have put red color litmus paper in this, and if it retains red, the color of the paper does not change at all, then it indicates that this solution could be acid. Let me repeat it once again. I have assumed that I have some liquid in this and I have put red color paper. If this is acid, the color of this paper will remain red. Suppose if it changes into blue, the same beaker when I and then I introduce a red colored litmus paper, and if it turns into blue, it turns from red to blue, then it indicates that the compound that is present here was essentially a base. Other way around, if you put a blue litmus paper, it will remain the same color. So please understand that the red coloration indicates presence of acids, blue colorations indicate presence of bases. So this is how we see with the support of this litmus paper. You can see a nice diagrammatic view here where they had actually introduced blue color paper here, turned into red. They had introduced a red color paper here, turned into blue. Similarly here also. So you have this universal pH paper. Now what is this universal pH paper is? We have pH values from 0 to 14. Now what is this 0 to 14 is? This 0 to 6 is acidic identifications. So if the pH value comes from 0 to 6, either you can talk in terms of value or you can talk in terms of these colors. So all these colors are acidic in nature. From 8 to 14, they are all basic, and there you see generally the blue color, blue or shades of blue, violet and all slowly coming towards green, whereas from down it is red going towards green. That central 7 value which is there, which is showing almost this greenish coloration of sorts, this is nothing but neutral. Neutral essentially indicates that both the compounds are equally mixed. So this is how this litmus can be utilized for that. It is extracted from dyes from lichens. Basically the stuff that grows whenever we grow these plants and all. So this is one type of compound which is available in plant generation where we can form this litmus. So having seen this part, the basic aspect of this, we now come across one important part which is pH. Now what's the full form of pH is power of hydrogen. It essentially indicates that what is the power of hydrogen ions present in that, and why do we talk with respect to this is because we have already studied that acids are those compounds which give H+. And then we happen to study that bases are those compounds which give OH-, but we have studied one important aspect. In fact, it was asked in an assignment also for you, where acids no doubt will have H+, but they will have some amount of OH- also. Similarly, bases no doubt will have OH-, but they may have small amount of H+ also, which indicates that you can just consider H+ and determine whether it's an acid, base or salt. So by using this, they formed this pH scale as such, which indicated that 0 to 6 they called it those type of compounds as acid. Now if the value was 7, they termed it under neutral, whereas 8 to 14 they called it as basic compounds. So this is how the pH values were given, and what it means is if more H+ is there, it is more acidic. If lesser H+ is there, then the acidic compound will be decreased. So that is what you see here that. So this pH is given by mathematical formula where pH, power of hydrogen, is nothing but negative logarithm of H+ ion concentration. The square bracket indicates concentration, and it is a negative logarithm. Now what does this negative logarithm mean then? It means that if H+ is more, concentration of H+ is more, the pH value decreases. Please understand this. If H+ is more, it indicates that pH value decreases. Now when is H+ more? It is more when more number of H+ ions are generated. And who generates more? Whoever is strong. If they are weak acids, can they generate more H+ ion? Definitely not. So therefore, we have to now see the correlationship between pH and H+. If H+ is more, pH is less, which indicates that if the pH value is 0, 1, 2 and all, it means very strong acids, because pH values are less if the H+ concentration is more. If H+ concentration is less, then it means pH value will be more. So generally all this 3, 4, 5, 6 and all, they are all generally those acids which are weak acids. And then on the other side we have this bases which will continue in the same scale. So what is this pH scale that we have here now is generally for standard measurement we use 25-degree temperature for our standard usage, where as already told to you, 0 to around this part will be acidic, this is the neutral part, and then we have this basic parts which are there. Now one thing we have to understand in this is that as you are going like this, because the formula was clear that pH is equal to, it was minus log H plus. So the moment it is minus log H plus, if H plus is decreasing, which means that acidity is decreasing. And acid and bases are exact river forms. We have seen that already. They are pakka rivers. So when H plus is decreasing, it means basicity is increasing. So you can see that these parts are highly acidic. Acidity goes on decreasing, but basic nature goes on increasing. So if I just talk about acidic nature will keep on decreasing as I go from this side to that side. Whereas basic nature which is present, since these are highly acidic, these will not be basic. So basic compounds will keep increasing in their values, and high basic compounds, you can have a pH value of around 40. So this is about the pH scale that we have a representation of this pH scale. So that value of 7 which is there is neutral. Moving further now. The same thing, the pH scale that we had, the same pH scale that we see here is now given in various coloration forms, because we have already seen that pH paper can give different colors in the systems. So what is this? You can see that this side it is more of a reddish coloration, where slowly it goes to greenish and then it is going towards the bluish part. So some examples are shown here where gastric juice is around this pH value, lemon juice, then pure water and blood more near 7. See, though neutral we say that it is exactly a value of 7, but then you don't find anything 100% exact. So minor variation in values will be there. So 7.4 still we considered it as neutral. Then milk of magnesia, this is a magnesium compound, and sodium hydroxide, which will have a very high value of around 14. So this is how we come across this pH scale representation. Now important thing that we see here is that how do we form an acid? It is basically, for example, if you had taken NaOH and if you had written with HCl, then you happen to form a compound like NaCl. Now the question is, what is the value of this NaCl which is present? So you can understand that if this was an acid, this was probably having a value from 0 to 6, or it is, say, let's say 7. So this is for bases. So this was, if you see the representation, let me represent it once again. NaOH plus HCl, it will give you NaCl plus H2O. So this being a base will have around 7 to 14, and this may have around 0 to 7. Now since both are strong base, strong acid, it will give a neutral salt, because both of them are strong. They will strongly react and then form a salt which is having a pH of 7. That is what the first sentence is. Salts of a strong acid and a strong base. Both are strong, both react equally. So they form a salt which is of value 7. But the question comes when you use a weak acid, say the second example which is there, strong acid and weak base. Now let me take an example of strong acid which is HCl. Let me take an example of a weak base which is NH4OH. Now what is the salt that is formed here? We can see that NH4 plus will be taken from here, Cl will be taken from here, and then as usual water is the byproduct. See, hydrogen has gone from here, OH has gone from here. Now will this also be measuring 7? It cannot, because this was highly acidic, strong acid. This was weakly basic. So who has the upper hand here? Naturally the salt that is formed, it will be little acidic. It may not be as acidic as, say, the strong acid like HCl. It will be little acidic. So you can't call this as neutral. So it will, because it is a little acidic, we already know that acids are those which have pH value less than 7. So therefore we understand in this case is that whenever the pH value is less than 7, they are acids, and why they have been acidic is because you have used a strong acid. Let's see the last point that is present here, salt of a strong base. Let me take an example of strong base, NaOH. Weak acid, let me take an example of weak acid which is, say, CH3COH. This we have already studied in acids part. What is the compound that you are getting? You are getting CH3COONA plus H2O. Now H went from here, OH went from here. This is called as sodium acetate. See, this is acetic acid. sodium acetate. Now the question is, will this be acidic, neutral or basic? Now please understand that this was strongly basic, whereas this was weakly acidic, which means that the power of base is pretty strong. So the salt that will be formed, it will be a little basic itself because of this dominating nature of strong base. And therefore, the moment it is base, what is the pH value? It has to be above 7. So that is why the pH values of such salts will naturally be a little more than 7. So this is all about the study of pH of salts that we can find, pH values, what are the pH for acid, bases, neutral compounds, how are the salts formed, all this can be understood by these parts. Now having studied all these aspects, it's now important to study certain applications of this in our day-to-day life. Do we come across anywhere acids, bases and salts on day-to-day basis? Definitely. With our own body, with our daily usage, with the surroundings, we have the application of these parts. So what are those applications? We will now be seeing those aspects now. pH sensitivity in plants and animals. Now the moment you are not feeling well, say suppose you get fever or anything, what's the first thing that you do? Your parents are hell-bent behind you to have you eaten some food, but you don't like eating anything. Because the problem is that the body is not functioning between the range of pH that should have functioned actually. Our body functions in that pH range, but if there is some upside down in our health, the pH value will change. It may become highly basic or generally tends to be acidic. So that is where our body is very much sensitive to pH. Even acid rain. So whenever it rains, you can see that if the industrial areas which are there, they leave out too much of gases. So the rain, when it is falling down, it will mix with all the gases that are being left to the air by the industries, and finally the air that we get will not be pure. So therefore this acid rain has become one important aspect where you can see that structures like Taj Mahal and all, they are getting deteriorated slowly because there are a lot of industries around Agra, and since they give out a lot of waste gases, the rain which falls will be combined with all these gases and it deteriorates the marble structure that is present. So similarly you can see other aspects where this acid rain, the same rain when it goes into rivers, tomorrow we are going to drink the same water. So overall what it says is, it affects our system and not just us, say animals, and even the plant fertility gets affected. So when you get acid rain for your crops, how do you expect the crops to grow in a natural way, in the best possible way? So naturally pH maintenance will be important as we as a body are very sensitive to it. Next aspect, pH in our digestive system. This is very important. The moment you eat heavy food, acidic food, your digestive system just stops to work function normally. What's the problem there? That is because when you have eaten acidic food, there is too much of acid in your stomach. It becomes very difficult for the body to function normally. So therefore we have to be very careful when we are eating food. We hear people undergoing some sort of a diet. What is that diet basically? It accommodates this one factor where pH of our body is maintained in those cases. There is another aspect where if you don't eat food, then what's the problem? Does that lead to acidity? Definitely. Because if you remember in the acid part we had discussed that our stomach produces small amounts of hydrochloric acid in less concentration. So if you don't eat anything, stomach keeps on generating hydrochloric acid. There is no food for dissolving. All that acid gets accumulated in your stomach. So over a period of time, you develop this problem of acidity. So therefore, it is important that we eat regularly so that whatever we eat is reacting with the hydrochloric acid that is present, and then it can function normally. That is why you can see that people who follow correct timings of food, correct quantities of food, correct methodologies of food, you see that they don't fall sick much. Whereas people who have a random routine of having food, they normally struggle with these digestive problems. So it's important, have the right kind of food at the right kind of time. So this is about the pH in our digestive system. I hope you would have seen the theoretical aspects that are being given here. I need not repeat it, I believe, because the same thing is what I have explained. Of course, if there is acidity in your body, then you can use this milk of magnesia, which is nothing but magnesium hydroxide, what we termed as one commercial example as ENO, where if you eat that, basically what happens is, since it is basic, excess acidity in our stomach can be neutralized in those cases. So this is about the pH in our digestive system. Then pH change as a cause of tooth decay. Tooth decay generally happens whenever our mouth has a lower pH of 5.5. In fact, the teeth that we have, the tooth enamel, is the hardest substance in our body, not the bones. It is the tooth enamel which is there. But even that gets corroded whenever there is a variation of pH value that we see. So this is important because it will not dissolve in water. Generally that corrosion happens whenever there is a variation of pH value that we come across. And that is because a lot of bacteria and microbes are generated in our mouth whenever lower pH is maintained. Please remember, low values of pH indicates high acidity. So the moment the pH values are lowered, it gives rise to such type of microorganisms. And how do we do that is, the role is done by the toothpaste, because toothpaste which are there, they are basic in nature. So what do this basic toothpaste do? They clean up all the acidic microbes or acidity that has been generated in our mouth. So that is how they are able to clear up all the microorganisms that have been present in these cases. So this is about the pH in case of tooth decay. And one final application, let us just see that self-defense by animals and plants through chemical warfare. Now what is the self-defense? They actually have a very good chemical warfare system between themselves. The moment you are bit by a honeybee, what happens there? First thing is, there is a bulge in your hand. Wherever it has bitten, there is a small bulge. Because it actually gives sting of the acids, methanoic acid and all, it actually gives that acid away. Now why does it give this? It is more like a chemical warfare defense system that has been present. You can see some pictorial representations here where whenever you are stung by honeybees and all, you get a lot of irritation also over a period of time. So the moment you are bit like this, the first thing that you have to do is put up some base. Because what the honeybee has done is, it has just given out its acid as a self-defense mechanism, because it probably feels that when it attaches itself to some body or when it has come in contact, it feels there is some attack on itself, and therefore it gives out this acid. So the first thing that you have to do in this case is look for some base, mild base like baking soda, because generally it will be there in your house kitchen. So that is one thing that can be used, because this will definitely cause burning, because there is an acid which is given out. So these are the various applications that we have regarding acids, bases and salts, how they are used by say even animals and plants, and how important our body is regarding the pH sensitivity. So having seen all these parts, let us see one last assignment in this case, and this being a last assignment, we have some general questions here. Write the importance of pH in everyday life. Some examples were dealt here, like say sting of a honeybee, pH in our digestive system and all. For your practice you can write it, but then it would be nice if you are able to find out some more examples by yourselves, not the same repetitive ones which have been told here. So find some new examples, how pH is actually playing a role in our day-to-day life. How do acids differ from bases with regard to chemical nature, then physical nature as well as indicators. So these are certain things. So physical nature, physically how they are, you heard some words, bitter, sour and all, properly put it up, which is for acid, which is for base. Chemical nature, you have seen various reactions, so there have been changes in the reactions. And then indicators, color, red, blue. So that is what you can tell there. So this is all about this particular chapter of acids, bases and salts. I would hope that you have understood the entire part very well, because this is having a very good application in our day-to-day life also. Thank you, and see you again with another new chapter in coming times. Sai Ram.